Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this video is regarding solving the next 10 good problems on the chapter of Algebraic Expressions and Identities. This is set 2 uh, where I will solve. So this video is part of the series of videos where I solve uh, 10 good problems which are under the category of HOT, that is high order thinking problems, which are relatively harder from the problems that we solved from the textbook of author R.S. Agarwal. Uh, so this video is part of the playlist Maths HOT 8, Maths 8 HOT. HOT stands for high order thinking. Where I solve 10 good problems of high order thinking from from every chapter that I complete in the other playlist, that is CBSE Maths 8 R.S. Agarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving 10 good problems of set 2 on the chapter of Algebraic Expressions and Identities. Okay, so I have the 10 good problems questions on the left hand side, and on the right hand side I will solve the problems. There are 10 questions, and all these questions are MCQ, that is there are 4 choices for each question and one choice will be correct. Ideally you should be able to complete these 10 questions in 40 minutes, taking 3 or 4 minutes to solve each question, and try to solve all the problems yourself first, and only when you are stuck then you can refer this solution video uh, for help. Okay, so let's start solving the problems. The first problem it is given that a minus b is equal to 5 and ab is given to be minus 4. We have to find the value of a cube minus b cube. Now whenever you have to find some values that involves cube of any variable, then you must remember the identities regarding the cube of variables, that is a minus b whole cube. A minus b whole cube is equal to a cube minus b cube minus 3ab and a minus b, and also a plus b whole cube is equal to a cube plus b cube plus 3ab into a plus b. And also there are two other formulas that is also very useful identities. A cube minus b cube is equal to a minus b multiplied by a square plus ab plus b square, and the next one is a cube plus b cube is equal to a plus b multiplied by a square minus ab plus b square. These formulas or identities you must always remember. Okay, so now we have to find the value of a cube minus b cube. Now we know the value of a minus b and ab. A minus b and ab. Okay, so if you so from we have a minus b equals to 5. If I cubing taking, so this implies if I take the cube of both sides, I will get a minus b whole cube equals to 5 cube. Now why I am taking the cube? Because I have to find the value of a cube minus b cube. So I need the power of 3. So from a minus b, the only way I can get the power of 3 is by taking cube of a minus b. And since I know the identity or the formula of a minus b whole cube, so this implies On the left hand side, a minus b whole cube, if I apply the identity, this is a cube, this is a cube minus b cube minus 3ab a minus b is equal to, we get 5 cube is 125. Now this implies, as you can see, we can see a cube minus b cube minus 3ab. Now ab we know is minus 4, and also a minus b we know is 5, is equal to 125. So directly we can now find the value of a cube minus b cube. So we get a cube minus b cube is equal to 125 minus 3 into 4 into 5. So we have on the left hand side we have a cube minus b cube. Let me see if everything's visible or not. Okay. So on the left hand side we have a cube minus b cube minus 3 into minus 4 into 5. So so that makes a positive 3 into 4 into 5, and when we move that to the right hand side, we get negative of 3 into 4 into 5. So this is equal to 125 minus 60, which is equal to 65. So 65 is the value of a cube minus b cube, and hence the correct choice is D. Correct choice is D. Okay, let's do problem number 2. It is given x square plus 1 by 4x square is equal to 65 by 16. Then we have to find the value of x square minus 1 by 4x square. Okay, now so we know that x square plus 1 by 4x square, we know that this is equal to x square, and 1 by 4x square means 1 by 2x square is equal to 65 by 16. So this implies we have x square plus 1 by 2x whole square is equal to 65 by 16. Now since we got something like x square plus b square is equal to some value, x square plus 1 by 2x whole square is in the form of a square plus b square. Now also note that if you are given a value of a square plus something like a square plus b square, you are given some value, let's say 3, and also you can and also a into b is a constant. Typically in some problems b will be the reciprocal of a, that is b will be 1 by a, but it may not be exactly 1 by a. It could be some variable where a into b will be a constant. So in this problem we can see that a is x and b is 1 by 2x, and x into 1 by 2x is 1 by 2, so it is a constant. So for this kind of problems, the way you should proceed to solve the problem is that we have to find x square minus 1 by 4x square. Now please see that we have to find the value of x square minus 4x square. So this is equal to x square minus 1 by 2x whole square. So this is in the form of a square minus b square, which will be equal to x minus 1 by 2x multiplied by x plus 1 by 2x. So we have to somehow find the value of x minus 1 by 2x and x plus 1 by 2x, where we know that we know the value of x square plus 1 by 4x square, and also we know that the two terms x and 1 by 2x, their product is a constant. So we will try to find the value of these two expressions, that is x minus 1 by 2x and x plus 1 by 2x. Now x minus 1 by 2x whole square will be equal to x square plus 1 by 2x square and a minus 2 into x multiplied by 1 by 2x. So this is equal to x square plus 1 by 4x square, and this is equal to 1. Now x square plus 1 by 4x square value is given to be 65 by 16. So we have 65 by 16 minus 1. This is equal to 65 minus 16 by 16. This is equal to 49 by 16. 49 by 16. Hence, x minus 1 by 2x whole square we got to be 49 by 16. So this implies x minus 1 by 2x will be equal to square root of 49 by 16. This is equal to square root of 49 by square root of 16. This is equal to 7 by 4. Similarly, using the same concept, we can find the value of x plus 1 by 2x. So we will have x plus 1 by 2x whole square is equal to x square plus 1 by 2x whole square plus 2 into x multiplied by 1 by 2x. Applying the identity, a plus b whole square is equal to a square plus b square plus twice ab. So this is equal to x square plus 1 by 4x square plus 1. X square plus 1 by 4x square value we know as 65 by 16. So this is 65 by 16 plus 1. This is equal to 81 by 16. So this implies x plus 1 by 2x will be equal to square root of 81 by 16. This is equal to square root of 18 by square root of 16. This is equal to 9 by 4. So now we can say we have found x plus 1 by 2x and x minus 1 by 2x. Hence x square minus 1 by 4x square 1 by 4x square is equal to x minus 1 by 2x multiplied by x plus 1 by 2x. So this is equal to 7 by 4 multiplied by 9 by 4. This is equal to 63 by 16. 63 by 16. So the correct choice is C. So after solving a problem, I will pause for a few seconds so that you can take the screenshot of the solution. Okay, let's do problem number 3. The expansion of, we have to find the expansion of, we have the product of 3 algebraic expression. First one is x square plus 4, the second one is x square minus 4, and the third one is x to the power 4 plus 16. Now we know that the first the product of the first two algebraic expressions is in the form a plus b into a minus b, where a is x square and b is 4. So this will be equal to a square, we know that a plus b multiplied by a minus b is equal to a square minus b square. Applying this identity, we can say the product of the first two algebraic expressions, that is x square plus 4 multiplied by x square minus 4, will be x square square minus 4 square, and this we have multiplied by x to the power 4 plus 16. Now this is equal to x to the power 4 minus 16, and we have multiplied by x to the power 4 plus 16. Again we have again we have got the form of a minus b into a plus b. So this will be equal to x to the power 4 whole square minus 16 square. So this is equal to x to the power 4, and then whole square is x to the power 8, and 16 square is 256. So the correct choice is D. D is the correct choice. Okay, let's do problem number 4. We have to, it is given that a cube plus 1 by a cube is equal to 62. We have to find the value of square root of a cube plus 1 by square root of a cube. We have to find this value. Now, as you can see that the cube, a cube and 1 by a cube, the power cube does not matter. What we have, what is given actually is we have to find the square root of a cube. If you notice that the power cube is not really coming into play, it will not be used. So if you can say let a cube is equal to x. So this will imply x plus 1 by x is given as 62, and we have to find the value of square root of x plus 1 by square root of x. We have to find this. You can easily solve, you can easily translate or reframe the given values as this, because the power 3, the cube, is not playing any role. Okay, so we have this. How do we find square root of x plus 1 by square root of x, where it is given that x plus 1 by x is 62? Now we certainly know that x is square of square root of x. Note that square of square root of x is equal to x. So basically what is given is square of x, this square plus 1 by square root of x, this square, is given to be 62. So this is of the form that a square plus 1 by a square is given the value a square plus 1 by a square, the value of a square plus 1 by a square, not a. So as you can see that we are given the value of something of the form, let's say t square. I am taking another variable name, t square plus 1 by t square is given, some value is given, that is 62. So from this, and also you know that t square multiplied by 1 by t square is 1, it is a constant. So from this value, that is t square plus 1 by t square, you can always find the value of t minus 1 by t and t plus 1 by t. So, and you can see that we are asked to find root over x plus 1 by root over x. Now we see that root over x plus 1 by root over x, if I take the square, its square is equal to root x square plus 1 by root x square plus 2 into root x multiplied by 1 by root x. This is equal to root x square is x plus 1 by root x square is 1 by x, and we have plus 2. Now we are given the value of x plus 1 by x. Even though originally in the problem it was a cube plus 1 by a cube, we have assumed that a cube to be x. So now we have x plus 1 by x equals to 62. So this is 62 plus 2 equals to 64. So this will imply that we have the square of x root x plus 1 or 1x 1 by root x whole square is now 64. So this will imply root x plus 1 by root x will be equal to square root of 64. This is equal to 8, and hence the value is 8, because we have assumed that a cube equals to x. So this implies that from this we can say that since we have assumed a cube to be x, this is equal to square root of a cube plus 1 by square root of a cube is equal to 8. So this is what we have been asked to find. So the answer is 8, and hence the correct choice is D. Okay, let's do problem number 5. What must be subtracted from x plus a into x minus a to give x plus b into x minus b? What must be subtracted from? So it is asking that we have this expression x plus a into x minus a. What must be subtracted? Let the expression that will be subtracted be y to give x plus b multiplied by x minus b. Okay, so we have assumed that the expression that need to be subtracted is y. So we have x plus a into x minus a minus y is equal to x plus b into x minus b. Now we know that x plus a into x minus b, x plus a into x minus a, using the identity we have, this is equal to x square minus a square, and we have minus y is equal to, the right hand side becomes, applying the identity a plus b into a minus b is equal to a square minus b square, we get the right hand side to be x square minus b square. So this implies if we take the y to the right hand side and the RHS to the left hand side, we get x square minus a square minus of x square minus b square is equal to y. So this implies y is equal to, if you open the brackets, we have x square minus a square minus x square plus b square. X square cancels out, and we are left with b square minus a square. So the expression that need to be subtracted from x plus a into x minus a to give x plus b into x minus b is b square minus a square, and hence the correct choice is B. B is the correct choice. Okay, let's do problem number 6. It is given that ax plus b multiplied by cx plus d is equal to px square plus qx plus r, then the value of q by pr is, okay. So as you can see, the right hand side of this equation, the right hand side we are having some kind of expanded form of the left hand side. So it is better we we perform the product of the two binomials given in the left hand side. So ax plus b multiplied by cx plus d, if you do the product using the a distributive law of multiplication over addition, we get ax plus b into cx plus ax plus b into d is equal to p x square plus qx plus r. The idea is to do the product of the two binomials on the left hand side, and then we equate the coefficients of x square, x, and the constant term from the LHS and RHS, and then we will get some relation between PQR and ABCD. So this implies again we have to perform the multiplication of ax plus b into cx, and it becomes AC x square plus BC x. Similarly, ax plus b multiplied by d is AXD plus BD is equal to P x square plus QX plus R. If you simplify the LHS, we have if I add the like terms on the left hand side, we get BCX and AXD can be since ABCD are constant, and also PQR are also constant. The variables are the only variable is x. So we can consider BCX and AXD are like terms. So it becomes BC plus AD multiplied by x and plus BD is equal to P x square plus QX plus R. Now if you equate the coefficients of x square and x and the constant term both sides, we get, if I equate the coefficient of x square from both sides, we get P is equal to AC, and if I equate the coefficient of x from both sides, we get Q is equal to BC plus AD. Similarly, if I equate the constant term, we get R is equal to BD. And so now we got PQ and R in terms of ABCD. So it has asked to find the value of Q by P into R. So this will be equal to Q is BC plus AD divided by PR. PR means ACBD. So this is equal to BC divided by ACBD plus AD divided by ACBD. This is equal to 1 by AD plus 1 by BC. 1 by AD plus 1 by BC is the value of Q by PR, and hence the correct choice is C. Okay, let's do problem number 7. If A is a monomial of degree m and B is a binomial of degree n, then degree of AB square, that is A multiplied by B square. A is a monomial of degree m, okay, and B is a binomial of degree n. Now, if A is a monomial, so a monomial means a single term, that is it will have a constant, that is it is a product of numerical factor and one or more literal factors, and the degree of monomial A is m means the sum of the powers of the variables in A is m. So and B is a binomial of degree n, and B is a binomial of degree n means it means that the degree of the highest term binomial is an algebraic expression having two terms. So the degree of the highest degree of the two terms is n. Then we have to find the degree of AB square, A multiplied by B square. Now, one thing to notice is that if you are given a binomial, let's say, consider B as the binomial A plus B, where A is a term and B is a term. Now, A and B are terms, which means that both A and B are a product of a numerical factor and one or more literal factors. That is, A could be something like it's a term, so it could be like minus x square or a b cube c. It's a term. It's a product of one or more literal factors and a numerical factor. So if B will be of the form a plus b, since B is a binomial. Now, when you take B square, what happens when you take the square of B? So B square will be equal to A plus B. So let's say let B equals to A plus B, where A and B are some terms, and obviously one of A and B must be having the degree of the degree n, because it is given that the binomial B has a degree n, which means that the highest degree of its two terms is n. So B square will be equal to A plus B whole square, which is equal to A square plus B square plus twice AB. Now, definitely one of the terms A and B must be having the degree n, So if A, let's say if A is the term that has degree n, then A square will have the degree twice n, because consider a term minus A. So it has degree. So degree of try to understand this point, that degree of x, y is equal to 2, because the sum of the powers of x and y is 1 plus 1 equals to 2. Again, see, degree of x, y whole square will be equal to 4. Also, degree of xy cube will be equal to 6. So what is the relation? So when you are squaring the term xy, its degree is getting multiplied by 2, because the degree of xy was 2 and the degree of xy square is 2 into 2 is 4. Similarly, when you are taking the cube of the term xy, its degree will be 3 times the degree of xy. So 2 into 3 is 6. Similarly, so if the concept is, if a term T has degree, let's say m, this implies that term T raised to the power n, where n is some natural numbers, will have degree n into m. This is the concept. If a term T has degree m, that is the sum of the powers of its variables is equal to m, then the degree of T to the power n will be equal to n into m. So the B square, the binomial B is a binomial. If you take B square, then it will be of the form B is of the form A plus B, where A and B are some terms, and B has a degree n. It is given that B has degree n. So definitely either A or either term A or term B will have the degree n. So B square is equal to A plus B whole square, that is A square plus B square plus twice AB. Now A square, the degree of A square will be equal to 2 into the degree of A, and degree of B square will be equal to 2 into degree of B. And so the degree of B square will be, from here we can say that degree of B square will be equal to 2 into degree of B, which is equal to twice n, because it is given that n is the degree of binomial B. Okay. Also, so what will be the degree of A into B square? A into B square. Now, A is a monomial. A is a monomial of degree m. So, degree of AB square will be equal to degree of A plus degree of B square, that is equal to degree of A is given m, and we have found that degree of B square is twice n. So the answer is m plus twice n. Now why it is that the degree of AB square is equal to degree of A plus degree of B, or degree of B square. If you consider A is a monomial, so let's say just to illustrate this, let's say A is equal to x square and B is equal to, let's say, x plus y. So degree of A, this implies a degree of A we can see is equal to 2, and degree of B we can see degree of B is equal to 1. Now A into B is equal to x square into x plus y, this is equal to x cube plus x y x square. So the degree of the polynomial x cube plus y x square is 3. Degree is 3. Now how come 3 is coming? 3 is coming from the fact that 3 is coming from 2 plus 1. 2 plus 1. So always remember that if you have the product of two polynomial, if you have, so the general concept is let P and Q are two polynomials of degree m and n respectively. This will imply degree of PQ will be equal to m plus n. So this is the concept. So for this problem, the degree of AB square will be m plus twice n, and hence the correct choice is C. C is the correct choice. Okay, let's do problem number 8. Problem number 8, it is given that x square plus y square minus xy is given to be 3, and also y minus x is given to be 1. Then we have to find the value of xy divided by x square plus y square. Okay. Since all the choices are numerical constants, so we can understand that uh, uh, xy, we have to find a kind of relation between yx and x square plus y square. Okay. Now, y minus x is given as 1, and we also have some value of x square plus y square minus xy equals to 3. Now you can only get x square, the term x square plus y square, if you take the square of y minus x. So from the given fact that y minus x is equal to x, if y minus x is equal to 1, if you take the square on both sides, we will have y minus x square is equal to 1 square is equal to 1. Now if you apply the identity of a minus b whole square, we get y minus x square will be y square plus x square minus 2xy is equal to 1. Now this implies that okay, now y square, we also know that from here, from this given fact, we know that we can say y square x square plus y square is equal to 3 plus xy, 3 plus xy. So if I substitute the value of x square plus y square as 3 plus xy, we get 3 plus xy minus 2xy is equal to 1. So this implies 3 plus xy minus 2xy equals to 1. So this implies 3 minus xy equals to 1. So this implies xy is equal to 3 minus 1 equals to 2. So we got the value of xy. Now if we substitute the value of xy in the given relation, that is this one, we get x square plus y square minus xy, that is minus 2, is equal to 3. So this implies x square plus y square is equal to 3 plus 2 equals to 5. This implies the value of xy divided by x square plus y square is equal to xy was 2 and x square plus y square was 5. So the answer is 2 by 5, and hence the correct choice is A. Okay, let's do problem number 9. So we have to find the value of 37 cube minus 28 cube divided by, we have 37 square plus 37 multiplied by 28 and plus 28 square. Now you can see that in this expression we are having cube and square of the numbers 37 and 28. So in the numerator we are having the form a cube minus b cube, and you must be familiar with the identity a cube minus b cube. A cube minus b cube is equal to a minus b multiplied by a square plus ab plus b square. So we can clearly see that in the denominator we are having the form a square plus ab into b square, where a is equal to 37 and b is equal to 28. Now 37 cube minus 28 cube, we can write it as 37 minus 28, that is a minus b, multiplied by a square plus ab plus b square, that will be 37 square plus 37 multiplied by 28 plus 28 square. and we have divided by 37 square plus 37 multiplied by 28 plus 28 square. So this term gets cancels out and we are left with 37 minus 28, which is equal to 9, which is equal to 9. So the correct choice is C. Okay, let's do problem number 10. Consider the polynomial p equals to minus 9 x to the power 4 minus 7 x square plus 7 x cube. Okay, so it is given that p is a polynomial which is equal to minus 9 x to the power 4 minus 7 x square and plus 7 x cube. Okay, so one polynomial is given, and it is saying it is given that m is equal to degree of p. Now, what is the degree of p? The degree of p is the highest degree of all its terms. Now, the highest degree of the term is the term having the highest degree is minus 9 x to the power 4, because 4 is the highest 4 is the highest sum of powers of variables in a term. So, the degree of p will be 4, and hence we have m equals to 4. Y is equal to literal coefficient of term of p with smallest coefficient. Now, what are the terms of the polynomial? It is minus x to the minus 9 x to the power 4 minus 7 x square and 7 x cube. Now, the term having the smallest coefficient is a minus 9. So this is the term with the smallest coefficient, minus 9. The coefficients of the terms are minus 9, minus 7 and 7. So the smallest coefficient is minus 9. So it is saying that y is equal to literal coefficient of term of p with smallest coefficient. So the term with smallest coefficient is minus 9 x to the power 4, and the literal coefficient of minus this term, literal coefficient is, I mean short writing LC, which means literal coefficient is equal to x to the power 4. What is the literal coefficient of a term? It is if you exclude the numerical coefficient or the coefficient of the term, whatever is remaining is known as the literal coefficient of the term. So for the term minus 9 x to the power 4, its literal coefficient is x to the power 4. So we are having y is equal to x to the power 4. What is z? Z is the term of p with smallest degree. Now the term with the term having the smallest degree is minus 7 x square. Minus 7 x square, because the sum. What is the degree of a term? Degree of a term is the sum of powers of the variables in the term. So we can see that x square minus 7x square is the term whose sum of the powers of the variables is minimum, that is 2. So z, hence we see that z is equal to minus 7x square. So then m by z, so we have to find the value of m by z. So this implies that m by z will be equal to 4 multiplied by x to the power 4 multiplied by minus 7 x square. So this is equal to, so this now becomes the product of three monomials. So we multiply all the numerical coefficients, that is 4 multiplied by minus 7, and we multiply the literal coefficients, that is x to the power 4 multiplied by x square. So this becomes minus 28 x to the power 6. Minus 28 x to the power 6, and hence the correct choice is D. D is the correct choice. So this brings to an end of solving the set 2 of 10 good problems from the chapter of Algebraic Expressions and Identities. I hope these sort of problems will give you a good practice to evaluate your understanding of the chapter concepts. So I will keep on making this kind of 10 good problems every now and then for all the chapters that I am completing in the other playlist, that is CBSE Maths 8 or S. Agarwal. I hope this video was beneficial to you. If so, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. Now if you have any questions regarding the series of videos, that is 10 good problems, you can let me know in the comment section whether you think these problems are good enough. They really belong to HOT, that is high order thinking problems, or whether they are easy for you. I would like to know your opinion, uh, your feedback regarding how you are finding these problems. So thanks for watching, and until the next video, take care and bye.